Hello everyone, today I'll be explaining position vectors. Now what position vectors are, it is a vector between 2 points. For example, in this figure, between point A and point B. Okay, so the points for point A are from the x-axis, it is moving 4 to the positive. That's 4. From the y-axis, it is 2 here. 2 meters, and from the z-axis it's -6 because it's going down by -6. Yeah. And now for point B, it is going opposite. You see the middle point of z is here, it is going to the opposite way, so that means the y is negative and it's -1. The x is +4 and then there's another 2, so that means it's +6. That means 6 on the x, -1 on the y, and 4 on the z. That's for point B. B from the origin, so you can call it OB, and you can call this one OA, because the origin point is O. Okay. So now, to solve for this position vector, to find the magnitude, the direction, all these, you're gonna have to add these two into a Cartesian form. Now, okay, so I copied them onto my notebook. So now from point A to point B, let's say it's traveling from point A to point B, you'll do OB minus OA. That would mean you do 6i over here. This is I, by the way, and this is 4i, so you do 6i minus 4i, that's for the i's, plus these, put them in brackets so you don't make a mistake. Now you'll have -1 minus 2j plus 4 minus -6k. Okay, so that will mean you have 2i minus 3j plus 10k. So that is the equation of our vector A, B. Okay, now to find the magnitude of AB, it will be AB, and you draw two lines next to it. Square root of 2 power by 2 plus -3 power by 2 plus 10 power by 2. Now the magnitude will equal to 4 plus 9 plus 100, which is square root of 113. That's the answer for the magnitude. Now for the angles, if you remember, it was the coordinates, the x value, it was 2 over square root of 113, I plus the square root of 113 on the bottom again, and this time it's -3j, and 10 over square root of 113k equals to unit vector of AB. Yeah. So let's solve this question here, which is F221, this one, over here. Okay, let's do it. Okay, this says there's point A to point B. Point A here is at 2 meters upwards for Z and 2 meters towards the x-axis. That means the coordinates for it are 2 for x, 0 for y, and 2 for z. For point B, it is 4 on the x, 3 on the y, and -4 on the z. So that means 4, 3, and -4. Now that is from O to B, and this one's from O to A. Okay, and now you add them and find the position vector between those two. Okay, so for this question, it's like a force directed along a position vector. So it's like the position vector does not start from here to here. It's just like a rope that's getting pulled, and this is how much force is on it. To find the Cartesian form of the force, you have to find the position vector and turn it into a unit vector of that position vector. Now, using the coordinates we found, let me show you how it's done. Okay, so now you have 2, 0, 2 for OA, and you have 4, 3, negative 4 for OB. Okay, now what you do from here, you do from A to B. From A to B, you do OB minus OA. So that means AB equals to OB minus OA. So AB equals to, what is 4 minus 2? It is 2I, and then for Y, 3 minus 0 is 3J, and negative 4 minus 2 is negative 6K. Now, to find the unit vector, you need to find the magnitude first. The magnitude of AB is square root of 2 power by 2 plus 3 power by 3 power by 2 plus negative 6 power by 2. That will equal to square root of 4 plus 9 plus 36, which equals to square root of 49, which equals to 7. Now that is magnitude. Now, for the unit vector AB, it will equal to all of the Cartesian form over the magnitude. Okay, so now that is 2 over 7I plus 3 over 7J minus 6 over 7K equals to UAB. Now you multiply that by the amount of force they gave you, which was 630 newtons. Now let's mention that the force is 630 newtons equals force. So now force times unit vector AB will equal to 630 times 2 over 7 plus 3 over 7J. This is IJ. So, and this is minus 6 over 7K. All in brackets. Okay. So yeah, for the unit vector times the force, 630 times 2 over 7I plus 3 over 7J minus 6 over 7K. Now that will be, if you do 630 divided by 7, that is 90. So now you have 180I plus 270J minus 540K equals to basically the Cartesian form of the force. Now that is the Cartesian form of the force, and that is it. Now here for this question, it tells you to find the Cartesian form of this force, and it tells you that point C is the midpoint between point A and B. So now, when you know that something is a midpoint, that means whatever the coordinates between A and B are, half of those coordinates will be the coordinates for C. So now, for example, the 2 and the y-axis here, the y-axis is here, it has 2 feet this way. Since C is in the middle, that means it only goes by 1 feet this way. Okay, it goes by 1 feet this way, and it goes by how many feet upwards? Since it's 6, it will be 3 here, 3 feet. And then for the x-axis, it goes by 1.5. So that means this one over here, it's 1.5 feet. So that means from C to O, you'll be going down by 3. So that's negative 3 on the Z. For the Y, you'll be going by positive 1 because you're moving to the right. For the X, you'll be going by backwards by 1.5, so that's negative 1.5. Now why C to O and why not O to C? Because the force is directed from C to O, so you have to find the position vector from C to O. Now, since you found the coordinates from C to O of the position vector, you will multiply the unit vector of this by the force. Now the unit vector, if you remember, was the unit vector of CO equals to these coordinates, which is negative 1.5I plus 1J minus 3K all over square root of every single one of those squared. Same thing. 1.5 squared, 1 squared, and negative 3 squared. Calculator. That will be 1.5 powered by 2 plus 1 plus 3 powered by 2 is 9. That will be square root of 12.25, which is 3.5. Okay. 3.5. So since 3.5 is on the bottom and these values are on the top, you do the force times unit vector CO equals to negative 1.5 over 3.5i, and all this multiplied by 80 by the way, and then you have plus 1 over 3.5 j minus 3 over 3.5 k. Okay. So for these values you will get for now we said 80 times 80 times in brackets you have 1.5 divided by 3.5. That is 34.29 or 34.3. That is 34.3i, and that is negative. This is the f from C to O, the Cartesian form. And now you do the same thing for 80 times 1 divided by 3.5, and that will be 22.85 or 86. So just 22.9 J. And then for K, do the same thing. We get 80 times 3 divided by 3.5, which will equal to 68.57 minus 68.57. Well, let me make this clearer so you can see it. F will be negative 34.3i plus 22.9j minus 68.6k. That is the answer. And that was forces along a line and position vectors explained. Okay, so here for dot product, it is between two vectors that have an angle between them. Those two vectors, you multiply their Cartesian form. And it will be equal to their magnitudes multiplied by the cosine of the angle between them. Okay, so there's this question here. I'll solve. You have the Cartesian form of the force that is going along this line. And now you need to find the vector for this one. And then when you find the vector, you can use it to find the angle. Now to find this vector, they already gave you the coordinates. It is 1 on the x, negative 2 on the y, and positive 2 on the k, or the z. So now let's call it from O to A, so that's vector A basically, equals to x is 1, so that's just I, y is negative 2, so negative 2j, and k is positive 2, so that's positive 2k. Now for force F and A, to find the angle between them, remember the equation was the forces dot product equals to the magnitude of each force multiplied by each other times cosine of the angle. So that means, what do you have now? You have dot product and you have the magnitude. Dot product, I'll show you how to calculate it right now. it is like this. Multiply both the i's together, that's negative 6 times 1 in brackets, plus multiply both the j's together, that's negative 2 times 9, plus multiply the k's, that's 2 times 3. That is the value of the dot product. So it'll be negative 6 minus 18 plus 6. So that means the answer is negative 18 for the dot product. So this one is negative 18. The magnitude, on the other hand, will be, for each one, you square root all of their coordinates. No, all of their Cartesian forms. Negative 6 powered by 2 plus 9 powered by 2 plus 3 powered by 2, which will equal to, now also for a, same thing, 1 powered by 2 will be 1, plus 2 powered by 2 is 4, and 2 powered by 2 is 4 again, so that is just 3. Okay, for this one it is 36 plus 81 plus 9, so that is square root of 1, 2, 6. Okay, now you do dot product over the magnitude equals to cosine theta. So now here, dot product, which is negative 18, over the magnitude, which was 3 times square root of 126, equals to cosine theta. Now you do cosine inverse and you will get the answer. And keep it on degrees, not radians.